There it goes.
Sweet.
The timer's going. Okay, so one, you had the right approach, right? We solved it algebraically, right? We did algebra, and we got the answer, right? This is the root. And here's another way we can kind of like check our answer. We can find the root or the zero graphically. Okay, so the equations can change and they can become more complex, but the approach would be the same.
Exactly.
Right? So get y all by itself on one side, everything else on the other side, and then set that equal to 0 and then solve that equation. Okay. So the third way to kind of solve it would be to do it numerically. And that's typically how you would do it in MATLAB. Okay. And what that entails is, let's just jump into MATLAB and do that. Right? Instead of the function being this algebraic thing that you can solve, we can say, well, I know that the x that I care about goes from, let's say, I don't know, -5 to 5. All right, so those are all my possible x's. Now I'm going to cheat because I know that it crosses the x-axis at x equals -2. So I'm expecting the value to be 0 right there. Right? Okay.
Yeah.
So then here's my function, y, and it's 2 times x. Now this is going to be a constant or a scalar 2 times a vector. So it's going to multiply each element of this times 2. Let's just do that first, right? Okay, so now we got...
Wait, because it's a scalar times a vector, you don't have to use a period?
Correct. Yep. If you don't remember which to use, just use the period, and it works just fine.
Okay.
We still get the same answer. Okay, and then what was ours? We put a constant, so we do +4. So here's the results of y. And look, here's my root. So I find y is equal to 0 right here. But which value of x does that apply to? Right?
-2.
Yeah, so it's -2. We can kind of see that up here, but to get MATLAB to figure that out, right, we can say, let me see, find where y is equal to 0. Let's see what I get. Right? Now I get a 4. What that means is the fourth element of y is where the 0 is. And then I can take that number, let's just give it a value of k for now. And then I can say, give me x of k, right, x of 4, so the fourth element of x, and it's -2. So now we have... Yeah, go ahead.
I was just saying, like, so yeah, that makes sense.
Okay. So now we have the beginnings of a program or an algorithm that finds roots. So I'm going to go into my command history and say, I'm going to click that guy, and then hold down Control. So like, I like that. like that and this, and then create script, right?
Yeah.
And then I can, just so this will be, portable to other functions, I can say I need to create an x vector, right? Now, if they have another variable in the pop quiz, like maybe it's t, right? Right, so I'm just going to say the variable on the horizontal axis, right? That's that guy. Okay, and then we need to calculate all the values of y, or if they have, maybe they call it f, like f of x or something like that, or f of t, variable on the vertical axis. Okay, so the function find, actually, let's open the documentation. So I'm going to click help, put it over here. So this finds the indices and values of non-zero elements. Okay. So the way this one works, if I just say y equals 0, all I get is this array of false, 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 true, false, 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 false. Right?
Yeah.
Which is basically, for each element of y, it's telling me true or false, is it equal to 0? Right? So then this is the thing that gets sent to the function find. And it says find the indices, this is what we're grabbing, where it's not 0. Well, here it is. It's not 0 when you're at element or index 4. Right?
What do you mean indices equals 0? Does that mean when everything... Would you mind going over that again?
Yeah, okay. So, what was x? Let's look at x. All right, so here's all the values of x. X, the first element, or the element where the indices is 1 of x, is minus 5. If I want to say, if I said find x equals negative 2, right? This is going to find this is going to result in the indices, or the element of x that's equal to minus 2. So what should I get if I press enter?
You should get the fourth element.
Yep, I got the fourth element. Right? And what if I just said x equals 5? Now this is going to say this is going to create that logical array of false or true based on whether that element of x is 5. So it should be false, 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 and then true right at the end. There it is.
And if you put 5 equals ABS 5, then it'd be true on both ends.
Okay, so is 5 equal to the absolute value of 5?
Well, I was saying, like, x equals absolute value 5.
Oh, I see what you're trying to get at. Okay, so let's just type this in, right? So when is x equal to absolute value of 5? It's still just going to be the positive 5 because this evaluates to 5, and then it's the same as evaluating this expression. If I wanted to say, if I wanted to find like true, whether it's 5 or minus 5, I could say find, well, let's just grab the ones, right? So then let's say the absolute value of x is equal to 5. So now, like, we took the absolute value of each element of x and then compared it to 5, and if it's equal, then we said true, 1.
Makes sense.
Okay, cool. Or if I wanted, oh, go ahead.
Are you going to move to basically when with chapter 5 in our book, it gets to discussing like bracketing, like you start with like a lower bound and an upper bound, and then you keep running like through it until the error of the calculated root gets to be like 5 decimal places.
Okay.
You heading in that direction?
I mean, we can eventually end up wherever you want. When you're doing root finding like that, are they using optimization? Are they using a function called fmincon?
Let's see. It's called it's chapter 5 roots bracketing method.
Okay. Yeah. So the only hard part about that is we just either we look in the book, you send me a picture, or we just look it up. Here's a root finding fixed point iteration that I did before with somebody. Bracketing, yeah. So then, all right, here's the algorithm, or here's a couple different algorithms. Bisection, false position, blah, blah, blah. Right, so then this is just a procedure, and then we'll take that procedure, or those steps and that equation, and just put it in MATLAB.
Okay.
Okay.
Want me to share with you a problem, or do you want to like talk through it and then we look at a problem?
No, yeah, share, like, yeah, take a picture and send it over.
All right, this.
So then we'd have to have the problem, and then I would need to see how your book is describing the method, whether it's like this bisection method, false position method. There are many different types, but.
All right, let me send this over.
Right. Stand by.
The stuff that's shaded is what's given.
What?
And then the stuff that I put, which is like, the stuff that's not is like stuff that I put, which I didn't know what I was doing.
Okay.
So.
Did you email it or text it?
Oh shit! I actually just took pictures of it and didn't do anything with it.
Okay, no sweat.
All right, here is. I texted.
Okay. Okay. I see him coming in. Oh, it's on your computer. Yeah, you can. Yeah, this is fine. But yeah, next time we can always just share screen, and then we can just look at it like that. But this is fine. Okay, so as shown, velocity of water discharged from cylindrical tank through pipe computed as this function. The variables are equal to all these things. Develop a MATLAB script uses the false position method. Ooh, that's what we like. To determine the initial head, which has to do with pressure, right? They talk about that?
Yeah.
Okay.
Okay, you go.
No, you can talk.
Well, I was just saying that I worked at a refinery last summer, so I know about like head stuff like that.
Okay. All right.
Just a little bit. Wouldn't be able to say about it, but
yeah. Okay, and then EAD.
Yeah.
What do you know that? Is that just error ED?
Yes. I think that's the error that the estimate has to pass and then it breaks.
Okay. Okay, so it's got to be that accurate. All right. The other thing that I think is kind of good to note is this stuff, right? Because you're gonna paste your function in here. False position method, right? And you're gonna put in a function XL, right? This is gonna be the input to your function.
Yes.
XUES max it variable arguments in. So variable arguments in is like, well, there could be one, or there could be none, or there could be like 4 other arguments. But that means you have to have at least these 5.
When I mean variable arguments in, is that where you put G equals 9.81, H equals head, all that stuff?
It would be anything you want to pass to the function. Have you ever written a function before?
Yes.
Okay. Have you ever written a function with variable arguments?
I don't think so.
Okay, well, let's try one. Okay, so function, whatever the output is, function name, we'll call it myfunc, and then I'm going to say maybe there's input 1, but then there's variable arguments coming in. And this is a special word, varargin. Okay? So what I would do inside my function is I would do like some detecting, right? So I have to be a detective, and I have to say, okay, so right now, all I'm going to do is I'm going to add everything that the user inputs into my function, right? So the first thing I'm going to do is I'm going to say it's equal to the input 1. Okay. And then I'm going to say if nargin, number of arguments in, equals, right, is equal to 2, then we need to take this variable arguments in and decide how to get information out of it. And it's not supposed to be a mystery, so var arg in. right? Variable length input argument list. So let's look in here, and let's look at some examples. Variable number of function inputs. Okay. So here, number of input arguments was 3. Here's one, here's some text, and pi. And then varargin 1 in curly braces gives me this, 1s of 3. Here's that text, and here's pi. Right? Now here's some where we have 2 inputs, and then it accepts additional inputs, and that's like the one that your professor is asking you to write. So total number of input arguments, 5. 1, 2, 3, 4, 5. Do you want me to zoom in, or can you see it?
Yeah, would you mind zooming in a little bit?
Sure.
Would you mind going back to what we just said real quick?
Yep, no sweat. Okay, so this guy expects 2 inputs.
Yeah.
And it accepts additional inputs as needed. Right? So here's 7 and pi. Those would be like the first variables that are like they're always going to show up. Like here's 13 and 42. Right? And then inside the function, you would write varargin, and inside that variable would be a cell array that's 1 by 3, so it contains 3 things: rand 4, daytime now, and hello. And then you would pull it out the way we pulled it out here with these curly braces.
Yeah, you're just saying what is the third input argument, or
yeah. This one, in this case, it's 3rd, 4th, and 5th.
So those are the 2. So that, so for that one, it would have been. Would you mind going back real quick?
Sure. No problem.
So for that case, the two defined inputs would be 7 and pi, and then you would code that as varargin, and then your varargins would be rand 4, random 4x4 matrix. Just make sure I'm clear on that. Your date time. What's up?
Yeah, it's going to be a random number between 1 and 4, but yeah, you get the idea.
Okay.
It runs rand on 4, and it gives you something.
Okay. Yeah. So then the first 2 are just arguments you need, but then the others are variable.
Yeah. Okay.
So what would be the reason to use the variable arguments? Like, I mean, is it just?
Yeah. So let's say, think of like an interesting example, right? Let's say I'm gonna model a car, right? People use MATLAB and Simulink to model cars and how they move, right? How they move around tracks, the suspension, and all that kind of stuff. So I could have some inputs to my function that tell me, okay, this is my tire pressure today. This is the road slickness, right? So into my simulation, it's either a dry road or maybe a wet road. And then a variable number arguments could be the weight of each of the passengers. But if I write in my function input 1, whatever, and then we say tire pressure, and then person 1 weight, person 2 weight, right? I can write this function and it would work with 2 people. But if I only put 1 person in, it's not going to work.
Yeah.
Or if
You
it's,
wouldn't have enough.
yeah, self-driving car, that's fine. So then I can say var arg in, and then I would expect if they put more than 2 inputs, it's going to be the weight of up to 4 passengers.
Okay.
Yeah. Do you want me to kind of code the rest of that and see what it would look like?
Yeah.
Okay. Let's see. Wetness. I don't know. We'll just say wet or dry. Okay. Yeah. Okay. So maybe I just got a variable in here that says b equals that, right? So it's either going to be true or false. Okay, and then tire pressure comes in, and maybe I'll just say P equals tire pressure. I'm going to use that in my function later on. So we're just going to write the beginning of it. And then if the number of arguments coming in is 3, then I would say var arg in of 1 is equal to, oh, sorry, my bad, other way around. So then this would be person 1 weight is equal to var argin 1.
Okay.
Or I can say else if, sorry, all together, nargin, if number of arguments in is equal to 4, then I would want to run, say, this line of code, and I would want to say this one is person 2. Person 2's weight is var argin of 2.
Okay.
Okay, and then maybe I want to display B, display P, display person 1 underscore weight, display person 2 underscore weight. Done. Okay, and then the output doesn't really matter right now. We'll just say output is equal to 1, so I give it a number. All right, hit save. There's my func. And oh, I'm in some other directory. That's fine for now. Okay, so let's call my function, and then I should give it right. I'm going to say true. It's wet, and then the tire pressure is going to be 33.3, and then I'm going to give it let's see, 200 pounds for one person, but then that's it. So if this works, I should get the wet or dry, display P, tire pressure. So it should display 1, 33.3, and then 200, and that's it. Okay, good. And this is expected because, right, the number of input arguments was 3, so it never created the variable person 2 weight. But then on line 14, I tried to use that variable to do something, but it didn't exist.
So
if you would have to write something in the code, either like if exist person 2 underscore weight, and it's a variable, right? So I mean that solves that problem, but I mean that's not really what we're here to talk about. We're here to talk about this part. If you put varargin, then you have the option of determining, based on the number of inputs that come in, what happens with the first of that input or the second of that input or whatever.
Yeah.
Okay. So that's how that works. Let's go back to my other folder. Oh, sorry, refunding. Yeah. Okay, so let's do a save as. Let's go. No, 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 no. Yes. What did they call it in your teacher's thing? There it is.
Call what?
The function.
Like in the book or the false position method?
Yeah. Yeah, what's the name of the function that we're required to write? False
function, bracket, root, comma, EA, comma, iter.
Okay.
Bracket,
and then equals?
False, POS.
Okay, got it. Okay, so that's what I'll call it. I'll call it false position. I'm going to name, so the file is named false pos, and then the name of the function inside, right, is false pos. Where is that? There it is. Oh, it's just hiding back here. Okay, and then let's start simple with just putting in function, right?
I can't see what you're typing. Is there a way for me, or can I just share my screen so you see my screen, and then I see your screen?
Yeah, yeah. On the lower right, where there's a square and an arrow.
Yeah.
Click that, and then click share screen.
All right. Probably share a window. That would probably make sense. Do you see it now? All right.
Not yet.
It says this will let you take over David as the main presenter.
That's fine.
Sure. There's a way that I can now see what you have.
Yeah, it's loading. Okay, now I can see yours.
No.
And then, yeah, if you want to focus in on something in particular, then you would click the little pin that shows up in the center of the image.
This?
Right? Yeah.
Right.
Or you can just like start moving windows around. What do you call it? Halvesies?
Yeah. Did that do anything?
Yeah, it looks like you can. Take your time.
Okay.
It takes a little while to just kind of play with it, see how it works.
Yeah, right now, all I think, do you see, how about, I can pull up the, I'll just pull up the thing on my phone. Just be primitive, I guess.
Okay. Okay. How's it going?
It's going all right. I'm just looking at this code and just trying to, it's actually probably feels good to just look at it and just not look at it like it's freaking Japanese or
Okay.
whatever. You know what I'm saying? Like a different language.
Yeah.
What's is empty?
Is empty is a function that tells you whether a thing, a container, a variable is empty or not. So you could say if varargin, is empty, then don't try to do anything with it. Or you could say if varargin isn't empty, then do something.
So in this case, on the default code that's given to us, if the number of arguments is the single dash, what does that mean? Does that mean if this is true and this is true?
The single dash, is it wavy?
The single like line, vertical line.
Oh, that means or. It's called a pipe.
Okay.
That's the name of the thing. Okay. And are you looking on your computer or your paper?
I'm looking on my phone.
Oh, okay, got it. Okay. So then it says if nargin is something or something else?
Yeah, so if nargin less than 3, comma, error, at least 3 input arguments required, end, or comma, end. If nargin less than 4, pipe is empty, in parentheses, ES, comma, ES equals 0.0001, semicolon, N.
Yes.
If
Oh, Y, so ES?
What'd you say?
You mean, is that Y, capital Y, lowercase ES altogether?
It's empty. No, it's empty, bracketed ES. I'm looking at the second page I sent.
All right. Ah, okay. Right. Oh, okay. So then, if they forgot to input ES, then we're just assigning it a value.
Okay.
And then the same with maxit. Maxit is less than or equal to 0 or negative. Then say, well, you know, hey, don't give me a negative number. I'm just going to put in 50.
Okay.
It's like some error checking when they put in there. Lower and upper guesses, decide relative error, maximum number of allowable iterations, additional parameters. Okay. All right. Well, I'm jumping on this side. I'll just kind of like code some of that. So we've got at least that starting point. Nargin is less than 3. Error. Yes. And if nargin is less than 4, or is empty, yes. Okay, can you see what I'm typing?
Yes.
Yes equals 0.0001. So the way they wrote it, I'm surprised they would even write it that way and give it to like people who are very new to MATLAB. But you know, this is how it would look if you wrote it in a proper I don't know way. I mean, that way it works, but it's harder to debug, it's harder to read, it's harder to understand. Okay, if number of arguments in is less than 5, or if max iterations is less than or equal to 0, bloop, then max iterations equals 50.
You said the pipe is or, right?
That is correct.
Okay.
Okay. All right. So then what they do is they take the function that was given, they input the lower guess and the variable arguments that came in.
Okay.
And then they multiply it by the function with the upper guess and the other variable arguments that came in. And then you should get, looks like you should get a if the test, right, if that answer is greater than 0, then there's no sign change. Meaning you didn't cross the x-axis.
Yeah, you didn't find a root.
Yep, no root. Good. Iteration 0, and then XR. What are they calling?
I think that's the x value of the root.
Okay. Okay. Great. So they just set it at then end. Okay. So they're setting those. It throws me with the end over there to the right. I don't know many people who write it like that.
Yeah.
Okay. So then they're going to write an infinite loop. So while 1 is itself, right? While true is true, then the lower bound's 4, the upper 0 and 4, then L is 4, T is 2.5, then make a linearly spaced vector, which I believe is from 0 to 4, but there's 100 elements of it. And then I guess move to the next page. Gravity is what it is. Okay. And then V is equal to so that we're just typing that guy in directly. All right. And notice they have the dot star in front of the capital H because it's a vector.
Just making sure you're clear on this. So everything under the WoW one was me.
Oh, okay. Oh, you wrote in the white space.
Yes.
Okay. Nice. So you've got.
I don't know what I was thinking by putting 0 or a vector linearly spaced 0 to 4 and 100 iterations. I think I maybe asked my roommate or maybe went for a Hail Mary egg or something. I don't know.
Yeah. Okay. Just felt right. But there's a good way to test. We just put it in MATLAB and see what kind of results we get. Right. Yeah. And the best thing, instead of typing it into the MATLAB grader right away, is put it in MATLAB. That way you can kind of like troubleshoot and see what's going on. Well, that's a good idea. Okay. So I'm going to go back here. Here. You going like that? Why is he going over to that person's stuff? All right. Okay. So where are we defining the function?
That's the first line.
Where?
First line if they give us function output root EA iterations equals func name, which is false position, and then inputs function lower bound, upper bound, ES, which is desired relative error, max iterations, and then variable arguments.
Okay. So FUNC is the name of the function, but where is the function defined? Right. So there's a couple of places you can define a function. You can define a function inside of another function. You can define it at the end of another function, or you can define it where it doesn't have to be sort of like defined in its own file. It can just be defined anywhere.
Okay.
But somewhere it would have to say, what is func?
Mm-hmm.
Right. Let's try that. All right. So take a look. Let's run something simple here. Okay. So we got some of this stuff. That's excellent. And let's have let's forget the output for right now. Right. Start simple. false pos, and it inputs a function.
Yeah.
All right. And let's say, so after all of the input stuff, right?
Yeah.
Output stuff, the meat. Okay. So let's say y equals func, right? And we'll give it an input. How about varargin of 1?
So that's the first.
Yeah, first element of variable arguments in.
Okay.
Okay. So then either in the command window, or let's just say in this script, this we're all just kind of commenting for right now, right? All I have to do in order to call my function is call this. Except I have to tell it what function is, and because out here is that garbage truck bothering you?
No, I can't hear it.
All right. Let's name our function my func.
Mm-hmm.
Let's say that it is a function of x, and it is equal to 2 times x. Right? Here we go. So if you type at and then a variable like this says I'm creating a function, but it doesn't have to have its own file.
It's an anonymous function.
Bam. I like it. Okay, good. So then instead of just some random function, right, I'm going to put in my function, right? And I want to put in 3. So I should get, because my function is 2 times, when I call my function from within false pos, it should give me 6. Right?
Yeah.
Let's make it y. Output in this case is y. Okay.
So, all right, that's nice because I never really understood why you used an anonymous function.
No, right? Yeah.
But that seems like a useful way to do it.
Right.
So, if you put, but you can't access that anonymous function in the file from the command window because it's a sub function of the greater function.
So this function, when I run this main script, its workspace is the base workspace.
Yeah.
Over here. That's the memory that it uses. When I call a function, this function right here only sees what I give it or anything that I calculate inside of it or anything that loads inside of it or whatever. All right?
Mm-hmm.
Okay. Cool. So if this function, just as like, right, so this function is an anonymous function that we're feeding as input into our false pos function. But if that function never changes, you could actually just include it down here as a nested function. Right? My func. X is the input, right?
Mm-hmm.
Y equals 2 times x. And there you go. So if it has a fixed value, then you can just write it right inside here, and then you don't have to input it every single time. So putting it as an input implies that the function may change. But that makes sense because we're going to feed it functions, and then it's going to give us roots. Okay. So anyway, introduction to nested function.
Well, we'll probably go over that more in the next few days.
Sure. Okay.
So when in this case, would you maybe say let's see what's changing in let's see what's changing in that problem. Let me pull it up.
Okay. So this one says determine the initial head needed to achieve a velocity of 5, and it gives you a function for velocity, but I would expect if you want to find like where a function is 0, where its roots are, then you would want to find where the velocity is 0, or maybe
it's the initial head that you need. That's the
right. So it's a root. It's a root finder. So something has to be 0.
Yeah.
What's going to be 0?
So the initial heads are going to end up at 0, or the height of the head is going to be equal to 0 once the root has been achieved.
Okay.
So basically what they're trying to say is, look, what should the initial head be if you got a pipe length M, you got a pipe length that's 4 meters long, velocity of the fluid or water is going to be 5 meters per second, and basically when after two, I'm confusing myself reading this. I don't know how you'd be able to pick this up. Let me see.
Yeah, no problem.
Finding the head needed to achieve velocity of 5 meters per second in 2.5 seconds in a 4 meter pipe.
Okay.
Your error should be looks like 7 decimal places, and your initial guess should be lower bound 0, upper bound 4.
Okay. Okay. So then the velocity changes based on the initial head and time. All right.
Yeah.
So let's just so we can like visualize it. Let's just put in some interesting things. So let's say time goes from 1 to 20, right?
Yeah.
And then let's say that velocity, let's just simplify the velocity and say it's just the hyperbolic tangent of t. And then we're going to plot time versus velocity. Yeah.
Yeah.
There it is. Of course, it opens up over here. Okay. So forgetting the other numbers for now, so it would start low, and then it would go up. because that's what the hyperbolic tangent looks like.
Yeah.
Right? Now, in this case, it's going to go to 1, but in the case in the example, it'll go to square root of 2gh, because that's the number that's multiplied by the result in blue that you see here. Okay, so let's just say that is say that's 20. Clear. CSC. Close. Okay. Okay, so that checks out, right? So now if that number up front is 20, it just goes up to 20. All right?
Yeah.
So now let's just put in the actual thing, square root of 2 times 9 to 9.81 times initial head, which is what we don't know. Right?
Yeah.
Okay. All right, so we don't put it in for now. Run it. So this is the approach. Like if you're stuck and you're like, what do I do? This is the start simple and build complexity a little small amounts at a time. That way you can be sure that each tiny step that you're taking is correct. And then you build up to something complicated from there. Okay, good. So this thing's looking normal. I feel like this shouldn't start at 1. It should start at 0. So I'm going to throw that in.
Yeah.
All right, this should be fine. Okay, so now the whole thing starts at 0. I feel better about that. Maybe I want, notice it kind of looks choppy right here. If I increase the resolution of t by doing like every 10th of a second.
Yeah.
Okay, good. So now it looks a little bit smoother. I like that.
Yeah.
Not bad. And then inside here, let's put in, is that t? It looks like the t is under the square root. Is it? Or no? I think it looks because it's italics.
That's a good question. Let me see.
I don't think it should be, because that would be weird.
It looks like it's under the T. I mean, if I drew a straight line downwards.
Yeah, but wait, it's italics. So draw an italics line that's angled. Right? The line that's parallel to the L that goes up.
It's weird because, I mean, I'm going to guess it's underneath the bracket because it extends over the T just about as much as it extends over the H and the coefficient of the hyperbolic tangent.
Okay. Okay.
I guess it wouldn't be a coefficient because it's variable.
Okay. Well,
you know what I'm saying?
Yeah, we can look at it and say that it's the same. So now I'm gonna take our equation that we had and make it a little bit more complicated, but I'm going to add some spaces in here just to make sure that it's clear what's going on. All right, so H I'm going to put in here, but I'm going to make it equal to 1 so that it basically doesn't do anything. And I'm going to say L is equal to 1 as well. So now the variables are in our equation, but we're not sure what those variables are yet. But I can still calculate V and plot it. All right, so let's see what happens here. Okay, so now look at that. It goes up a lot faster, and it kind of like hugs this. Okay, now we got to put the square root of that. I'm leaving the t out of the square root for now. That's the difference that makes. Let's say the t has to go under there.
Yeah.
It was 20. It looks like you can't tell the difference visually. There's probably a difference, but can't see.
You're plotting T versus T, right? Yeah.
Yeah, T versus V. Okay. Now, like for my comfort level, I feel like T is outside the square root.
Okay.
But so let's go with that assumption and see how it goes. Okay. So the initial head is going to be something, and the length is going to be something else. Now, is that going to be something that we input into the function, like in the varargin section, maybe?
Well, it looks like it almost looks like we should solve the equation for h, if that's possible. Is that possible? It may not, or it may not. I think it's actually not. It may not be possible, so that we're forced to use this, use MATLAB to help do that. Because it looks like the only unknown is going to be the head pressure that makes it so that all of this is true, right? So I guess it'd have to be you'd move V over, you'd put 2GH or root 2GH hyperbolic tangent, all that stuff in brackets, minus V equals F of capital H.
Yeah.
Yeah.
Okay. Yeah, that could be it. Let me look at. Okay, this is false. Find false. Okay, false position method. Root finding. Sorry, similar to the bisection. Instead of bisection, search middle of the interval. It uses x-intercept of that line that connects the plotted function values. Okay, so it's like, oh, we have to read about the bisection method first and then come back. Then it says, go read secant method and then come back, because it says it's like that, except instead of retaining the last 2 points, it makes sure to keep 1 point on either side of the root. False position can be faster, etc., etc. That is so-and-so is a thing. Okay. The simplest root finding algorithm. So if they're saying that false position is similar to bisection, we could probably just try to implement the bisection, and then we just have to modify it slightly to make it the false position one. Right? At least get something going.
Yeah.
All right. And then while talking about this, what I'm thinking in my mind is, where's my function? What are the inputs? Right? Because that's what I have to feed in here. Okay, so the function has to be continuous. So far, ours looks continuous. For which one knows an interval A to B. All right, so we got an interval. It looks like our interval was 0 to 4. Am I right?
Yes.
Initial guesses were 0 and 4, right? So T is not our independent variable.
No, our independent variable.
T is 2.5. Right? The independent variable is h, or in this case, x. We're just changing it to x.
X
and
being
L is 4.
X being the initial head.
Okay, so in our function, G is a constant. So
yes.
Forget G.
Yes.
H is a variable. And
yes.
It could go anywhere from 0 to 4 meters.
Yes.
Okay. L is a constant. It's 4. Because we're determining initial head for a 4-meter pipe.
Yes.
Okay. And then V, they're saying, is equal to 5. So this function is not a function where V equals something anymore.
Yeah, so V is not the dependent variable. We're making it a constant.
Yeah.
So that's why we move it over. You say what V equals minus V equals function of head. Right?
Okay, so then our function, we need to manipulate this equation so that it's basically h of t.
H of t. Well, the thing is, I don't think you can manipulate it. Like, I don't think you can isolate H on one side.
Right, okay. Well, might be able to. What time is it? 18. Okay.
You have another session soon?
No, just in 12 minutes. Fine.
Okay.
Let me share my other screen so that I can start writing stuff here. Because I feel like, writing stuff, I'm not ready for that. Entire screen, share. All right, see that other screen, I guess?
Yeah.
Okay. All right, so V equals square root 2GH H over L times T. Okay, so let's just assume we could get it in this form, or we can use MATLAB to do it for us. That we have some function h of t.
Yeah.
So we can look at h is only the initial head, though.
Yes.
So this is not right. Okay, so y equals 2x plus 4. Let's go back to this one, right? So some value of x ends up with this at 0.
Mm-hmm.
Okay. So
some value of h equals b equals 2.5.
okay.
Go ahead, right?
Okay, so that's not a root. But we're going to use the false position method to do that? Okay. Maybe I'm pretty rusty at this then. If that's the case. Okay. So we're going to say, so everything's in here. 2 times 9.81. Oh, my screen's about to break. Yep. Oh. You're killing me. Okay. You still there?
Yeah.
Okay. Sometimes my monitor doesn't like it when I write on my lower screen. So that's fun. So now I can only see like one tiny little thing at a time. And like my memory for like going back and forth between look at this, then look at that, and click on this slide and go back, it's horrible. All right. So you have to help me out. Okay, so then h is a constant, but we don't know what it is. Right?
Yeah.
So it's a variable.
Yeah.
Make it lowercase square root of g times h over L t. Okay, and this L, this was 4 meters. This was 9.81 meters per second squared. And t is not a variable. It is 2.5. Okay. Okay. So what we have right now, if we're understanding the problem correctly, we have one equation and one unknown. So then, in this case, this is not a root finding problem. This is just how do I solve this equation? Or like you're saying, like maybe I'm thinking of a root finding as it finds a 0, but you're saying, well, figure out what h makes this equal to 5, and then you can use the same procedure as a root finding, but you're looking for 5. So like it's weird. So like in that example, you would look for, here's a positive value, here's a minus value. So it means somewhere in there, there's a root or a 0.
Yeah.
Okay. So if we're going to do it in this case, we wouldn't say positive minus. We would say up here it's greater than 5, and down here it's less than 5. So somewhere in here it crosses 5.
Yeah.
Okay. And when is this due? Oh, it's going to happen as a pop quiz sometime today.
This homework was due yesterday. I mean, my homework grade is fine.
That's okay. All right.
The quiz, I don't know. probably look into it, maybe check the forum, see what's going to be over. But it's probably not going to ask me to do all of this. It's probably going to be like, which of these procedures will give me this?
Yeah.
Multiple choice type thing. And if, I don't know, I'll just plug in the error functions in MATLAB.
Yep. Okay, so one way you can sort of like see if you're heading in the right direction, like if you had a polynomial like this, you could feed them into the function roots, and it'll give you the roots of the equation. Roots function considers P to be a vector with n plus 1 element for the nth degree characteristic polynomial, blah, blah, blah. Okay. And then let's check F0. So then, because you've got hyperbolic tangent, there's a non-linear function root finder where you feed it the function, right? Like as an anonymous function like we did before, right? With the @ sign. And you give it an initial point and it gives it. So you can use that function to help, like basically find the answer and then write your algorithm so that it gets the same answer.
Yeah.
Right. I mean, this is all just like redundancy because MATLAB already has this stuff in it. It's just going through the exercise so that you can learn the ins and outs of MATLAB, which, in my opinion, is garbage because it's weird and it has there's no context for it. But,
what, MATLAB?
No, like if you're going to be a mechanical engineer, like you're not going to go out into the world and write a root finding algorithm, you know?
Yeah, I think
you're gonna analyze the trusses on a bridge, or you're gonna say like what's the structural integrity of this column or something, you know?
Yeah.
Plane.
Did you major in mechanical engineering? Just curious.
My undergrad is in aerospace, and then my master's is in mechanical.
Oh, nice. Anyway, well, I'm probably going to study up a little bit, probably take another hour or so to maybe run through, work on it, then take a quiz.
Yeah. Okay. So let me tell you, this is how the bisection works. And if we're going to do it this way, this is the bisection says, let me start at the endpoints. Right? I'm going to start at this end of my function and this end of my function. So if this one was negative, or in our case, less than 5, and this one is more than 5, so then somewhere in here, it crosses.
Yeah.
Right? Okay. Then it says the midpoint is a plus b over 2. And then you look at so the midpoint would be somewhere in the middle here. And then you look in here. So you look say, is this less than 5? And this is greater than 5? Well, then this is the area that I care about. So then I'm going to get a midpoint right here. Right? I'll put that in. And now I'm going to say, what's the value of the function here versus the value of the function here? And the value of the function here versus the value of the function over here.
Okay.
Oh, it's over here. So then you start narrowing down. Eventually.
All right, now let's see where this code comes from.
Okay.
Sorry to interrupt, but
no, that's good.
Yeah. So you start with your initial guesses, x upper, x lower, and then you have your x midpoint. If x midpoint times the value x lower is negative, then x midpoint becomes your new upper bound, and then it keeps on cycling through iterations until you're
until you're like so close to 5 or so close to 0 that you're within 0.000001 or whatever of your answer.
Yeah. All right.
Okay.
I think that 3-minute explanation is probably more valuable than an hour lecture from my professor.
Okay, so here's where the x value in bisection in the false position, use this formula.
Okay. Would you mind emailing me that Wikipedia page?
Yeah.
All right. Thank you.
Okay, cool. Yeah, I'll talk to you later, man.
All right.
I'll put the video up too.
All right. Thank you.